Good noon, everyone. Today discuss about the computer-aided process synthesis CAPS unit number 4 optimum approach temperature. In a previous section में આપણે threshold temperature જોયું હતું. તો start કરીએ. Optimum approach is temperature. First of all the discussion and also graphically system. Okay. The importance of the minimum approach temperature for a delta T minimum. હવે ડેલ્ટા ટી મિનિમમ પણ 10 આપેલું હોય તો જે આપણે હોટ ફેઝ અને કોલ્ડ ફેઝ માટે જે કોલમ બનાવીએ છીએ એમાં 10 પ્લસ અને 10 માઇનસ કરવાનું જે હોટ ફેઝ અને કોલ્ડ ફેઝસનું હોય તે જે આપણે કમ્પોઝાઇટ કર્વ મેથડમાં જોઈ ગયા હતા has been emphasized in the previous section part. So clearly the delta T minimum tends to 0 basis and the true pinch is approaches at which the area for heat transfer approaches for an infinity is a infinitive while the utility requirement are reduced to be the absolute minimum. Again repeated, the importance of minimum approaches temperature delta T minimum has been emphasized in the previous section part clearly as a delta T minimum tends to 0. The true pinch is approaches at which the area for the heat transfer approaches infinity while the utility requirement are reduced to the absolute minimum. At the other extremely, as the delta T minimum tends to infinity part, the heat transfer area approaches 0 and the utility requirement are increased to the minimum with no heat exchange between the hot and cold stream માટે. The variation in the heat transfer area and the utility requirement with the delta T minimum translate into the variation in capital and operating cost shown schematically in figure 10.27 માં જોઈશું આપણે જે ગ્રાફિકલી સિસ્ટમમાં છે this one. Trade-off between the capital and utilities cost as a function of delta T minimum. Okay, and what is the graphic basis cost versus delta T minimum? જે tends to 0 માં હશે या 0 અથવા તો ઇન્ફિનિટીવમાં બેઝ પર હશે જે ડેલ્ટા ટી મિનિમમ tends to 0 or infinity. ઓકે જે કેપિટલ અને યુટિલિટીસનો ગ્રાફમાં આપ્યો છે યુટિલિટીસ છે સ્ટેટ ગ્રાફિકલિસ્ટ છે અને કેપિટલ એ કર્વ બેઝિસમાં છે. Okay, the delta T tends to infinity. The heat transfer area approaches 0 and the utility requirement are increased to the maximum with no heat exchange between the hot and cold stream. The variation in heat transfer area and utility requirement with delta T minimum for translate into the some variation in a capital and operating cost shown schematically in a figure wise as discussed into the previous section part. As delta T means the decreases, the cost of the utilities decreases linearly until a threshold temperature delta T threshold is reached out, the below which the cost of the utilities is not reduced, thus the delta T minimum and the very much less than delta T threshold. The trade-offs between the capital and utility cost do not apply this formation. In a summary, when designing for the heat exchanger networking, it is important to consider the effect of the delta T minimum. The next example illustrates this effect while applying the technique for stream matching described in the section 10.3 basis. Okay, now the solving the example. This basis is the data. Write down your notebook. For a stream આપ્યું છે કોલ્ડ અને હોટ ફેઝ માટેનું અને ટેમ્પરેચર કેલ્વિનમાં ફોર સ્ટ્રીમ અને થ્રેશોલ્ડ માટે અને કેપેસિટી આપી છે સ્પેસિફિક એન્ડ ધ રેટ ઓફ ફ્લો એ રીતે આપણે સોલ્વ કરવાનું છે એક્ઝામ્પલને. તો ડેટા જોઈ લો એક વખત ખાસ કોલ્ડ અને હોટ ફેઝ માટે અલગ અલગ ટેમ્પરેચર્સ આપ્યું છે. Now consider the design heat exchanger networking for 4 streams in the problem generated initially by this 1977. The stream માટે કોલ્ડ માટે અને હોલ્ડ માટે ટેમ્પરેચર છે 269.3, 533.3, 494.3, 477.5. એ જ રીતે થ્રેશોલ્ડ માટે 488.7, 317.5, 383.2, 316.5. Now the capacity is kilowatt per Kelvin 36.93, 10.55, 26.38, 15.83. Now the Q 8102.44, 2286.19, 2930.82 and 2548.63. The following specification apply the cooling water at the temperature stream માટે 310.9 Kelvin અને threshold માટે less than equal to 355.4 Kelvin અને cost of the cooling water માટે જોઈએ તો 0.11023 $, per 1000 kg. And stream standardized T is equal to 508.7 kg Kelvin. Delta H vaporized form is equal to 1782.2 kilojoule per kilogram. Cost of the stream is equal to $2.2046 per 1000 kg. Now the overall heat transfer coefficient U is a heater form is equal to 0.3508 kilowatt per meter square Kelvin માં અને U cooler is equal to U exchanger is equal to 0.2629 kilowatt per meter square into Kelvin. Write down this data in your notebook, and then I will discuss about the for explanation part. Now again discussion part for ઓવરઓલ હીટ ટ્રાન્સફર કોફિશિયન્ટ વેલ્યુ આપી છે તમને અલગ અલગ. પરચેસ કોસ્ટ ઓફ હીટ એક્સચેન્જ જોઈશું. સીપી સ્પેસિફિક ગ્રેવિટી 1546 Armstrong is the raised to 0.6 dollar per meter square. And equipment operability તમને આપેલી છે 8500. and return of this investment IM is equal to 0.1 for equation 10.3 ના બેસિસ પર જોઈશું આપણે. for solution part is there for this example. when delta T minimum very much greater than delta T threshold is equal to 25.833 Kelvin, two pinches exist. This is because the heat capacity flow rate of streams H1 and H2 sum of the heat capacities flow rate of stream C1. Consequently, when the delta T minimum is equal to 30 Kelvin, at the first pinch the hot and cold streams temperature are 494.3 Kelvin and 464.3 Kelvin, and the second pinch the temperature are 477.5 Kelvin and 447.5 Kelvin. The temperature interval between this temperature involve just streams for H1, H2 and a cold phase C1, and hence delta T is equal to 30 Kelvin throughout this interval. Above the pinch a steam provide 490.7 kilowatt, and below the pinch cooling water removes 153.89 kilowatt. Okay, and below the pinch cooling water removes the values of the 153.89 kilowatt. This minimum utility requirement at delta T minimum is equal to 30 kilowatt as shown in a figure 10.28a, this one. Okay, now this is shown a graphically system. Temperature into 10 is to minus 2 Kelvin and Q into 10 is to 3 Kelvin. This graphically system for a composite heating and a cooling curve, for example 10.14 delta T minimum से 30 Kelvin and a minimum threshold से 25.833 Kelvin. Okay, this is a hence example for the first part. This is the solution, is the last one there. Now when the delta T minimum (25.833 Kelvin), the temperature of the hot stream the pinches are unchanged, but the temperature of the cold stream are 468.5 Kelvin and 45.17 Kelvin. In this case, on the low temperature side of the pinches also the no cooling water is required because of the composite cold curve. Begin when the composite hot curve and shown in figure 10.28 basis. The figure shown the design for three heat exchanger networking system having a minimum utilities at three values of the delta T minimum. Okay, तो अलग अलग वैल्यू आपी है. The former is reduced because the cooling water exchange is no longer needed at a delta T minimum is equal to 16.9 is much simpler because no pinches exist as shown is figure. Okay, this one. Now the delta T minimum when they compared with the other two network is having minimum utilities in the latter has the lower analyzed cost. For a more realistic comparison, the hit loops in a figure this one. Okay, the broken to determine whether a lower analyzed cost is possible. Next lecture में जो सो अपने this theory. Thank you so much.